Hi, everyone. Hello. How are you doing today? All right, awesome. Thank you very much for joining my talk today on how to accelerate local development on Kubernetes using Telepresence. My name is Edidiong Asikpo. My name can be quite hard to pronounce, even for people who are from Nigeria, right? Because we have different tribes in Nigeria. So if you're not from my tribe, it can be a bit difficult to pronounce. So I often go by Didi. So if you can't pronounce it Edidiong, it's absolutely fine. You can just call me Didi. So I work as a senior developer advocate at Ambassador Labs, and I often like to build developer communities, contribute to open source, and write technical articles. Here's a quick overview of what we'll cover today in this talk. I'm going to share a bit about how the developer experience has changed since we started adopting cloud-native technologies and development practices, and then go further into explaining how one of these change has significantly made the inner dev loop slower, which in turn makes it a bit harder for us to ship features to our end users as fast as we want to. I'll share different scenarios of how people currently develop and test microservices, and then show you how Telepresence kind of combines both of these two methods, combines the pros of these two methods rather, and makes it something better. Then we'll do a quick demo if the demo gods allow. I also have a video just in case the internet is not as fast as I want it to be, so I could just talk through that video. But if things go well, then I'd love to do the demo here as well. Then we'll do a quick conclusion and have a Q&A session. All right, so how is the developer experience changing? Before I talk a bit about this, I just thought it would be great to quickly talk about what developer experience is. I feel like maybe all of you here already know what it is, but let's just think of this as a quick reminder. So developer experience is the process, or is the workflow a developer uses to develop, test, deploy, and release software. So you can think of this as the exact moment where the developer starts writing code, up until the point where the code changes, is being deployed, or sent or accessed by the end users that they wrote it for. So typically, this experience consists of the inner dev loop and the outer dev loop. So what's the inner dev loop? The inner dev loop is pretty much the process or the time where the developer writes the code, let's say, for a new feature, or they're trying to fix a bug. And when this happens, they'll typically want to test the impact of their code changes. Then if things don't go well as planned, then you go back, refactor that code changes, and retest again. And then once they're fine with the impact of the code changes that they've made, the next step would be to push it to a registry, like GitHub, version control system rather, like GitHub, GitLab, or whichever one you use. So as soon as this push is being made, it automatically triggers the outer dev loop. So the outer dev loop is pretty much what happens from then on up until the release. This could include things like code merge, canary releases, or observability. Those are the kind of stuff that happen in the outer dev loop. So let's talk about that change. Ever since we started adopting cloud-native technologies, it has altered the developer experience in two ways. And the first one is that it's added extra steps to the inner dev loop. I'm going to talk a bit about that in the next slide. And then the second one is that developers now have to be more concerned with the outer dev loop. Things like releasing, monitoring. We didn't really have to be so concerned about that previously. That's before we transitioned to cloud native. But now we have to think about all of those things. And then it's also somehow involved in our workflow. So I know a lot of people like to move past the extra steps added in the inner dev loop. They're like, oh yeah, I mean, I still get to use Kubernetes. I still enjoy all of the benefits, so it's fine. Those extra few minutes or hours does not do anything. But let me give you a quick scenario. So here is an example of what the inner dev loop used to look like before the adoption of cloud-native technologies. So assuming that the developer had to spend, let's say, 6 hours per day, that might not be ideal, but let's say 6 hours per day coding, and then they were going through an iterative local development cycle for 5 minutes. This means that, let's say, coding took 3 minutes, they would have to build in 1 minute, inspect in 1 minute, and then take 10 to 20 seconds to commit their code changes. So what this does is that they had like a process of being able to like get their feedback loop a lot faster. And the only thing that took time there was maybe trying to write a very good commit message, right? But here's what it looks like with containerization. As you can see, the difference between this and this is that there's now a new step there. The part where you have to build the containerize the application, push it to a registry like Docker Hub or Quay by Red Hat, and then deploy it to a Kubernetes cluster to test your changes. So if it would have ideally taken someone, or rather if it would have given a developer an opportunity to have 60 iterations when they were working with monolithic architecture, with microservices now, it would brought down up to 40%, right? So, and this is like 20% out of the ones that you could have actually shipped or pushed to your end users. So this slow inner dev loop makes it a lot harder, right? So think of it this way. I see there's like a bug somewhere, my manager asks me to go and fix that bug. I do my magic, try to make a code change, and then I want to test that code change. Instead of having to just follow the normal route where I could build and click on hot reload to see the code changes, I now have to containerize that application, push it to Docker, and then deploy it to the Kubernetes cluster before testing it. And most times for certain applications, right, it can be like really, really large. I've tried to push something to Docker before, and it took me like minutes, sometimes hours. Again, things like let's say your internet connection comes into play, or just that your computer is not as strong or as powerful enough. So you get to spend like some minutes or an hour trying to push this thing to Docker. So let's say you eventually push this, right? You deploy it to the Kubernetes cluster, and then you test it, but you realize that, okay, it's not going as you planned, like this is not what you wanted. So you have to go back to your IDE, make the code change, and go through this entire process again. If you understand what I'm saying, you'd see that these extra minutes and these extra hours that you're spending could have been used for something more productive. So, for example, a front-end developer would have to wait for previews of a back-end changes on a shared dev environment or rely on mocks when coding their application locally. And then a back-end developer, on the other hand, would typically have to wait for CI/CD to build and deploy the application to a target environment to verify that their code works correctly. So this basically says that this slow inner dev loop doesn't just affect individual developers, it affects teams as well, because I would typically have to wait for this team to do stuff before I can go ahead and move forward. And all of those extra minutes or hours can affect our productivity or not help us to ship those features as fast as we want to our end users. So is there actually a way out? Is there a way to still enjoy the many benefits of Kubernetes without having to struggle or face a slow feedback loop? Yes, and there are a couple of them which I will walk you through. So the first one is trying to run everything locally. Of course, doing this would give you certain benefits like adding breakpoints. If you're using NPM, you can even enable hot reloading, and a couple of other interesting stuff that comes with being able to run everything locally. But of course, this would work for like, let's say a cloud-native application that has a couple of services. There's a certain point in time where your app becomes too big that it can no longer run on your computer, right? So it then means that you have to move away from running all of this locally. So here's the pros and cons of this method. So the pros here is that it's very cheap because, I mean, you don't have to necessarily pay for anything. You can use like Docker desktop or whatever, and then it's like on your computer. And then the maintenance is quite high because you always have to update like those mocks, update the scripts that everybody's using. And then the workstation temperature is hot because, I mean, sometimes even when you're just joining a Zoom call or trying to respond to stuff on Twitter or doing a Slack message, your laptop starts becoming hot. So imagine when you're running an entire cluster or running different databases, it can make your laptop hang, and that's not what you want. But then the dev loop for this is actually very fast because everything is happening locally. You make the code change, Docker build, you deploy, and then you see how it will work with the other services. And then there's also the option of running every single thing remotely. This is the process I talked about earlier where you have to containerize the application, that's the code change you've made, deploy it to whatever registry you use, and then now deploy it to the Kubernetes cluster to test the impact of your code changes. This is cool as well. It also has its many benefits. But then the thing is that you always have to wait for all of this to happen. Imagine if you're running like a Java application that is like super big, it would take a lot of time. Or let's say you're in a place that doesn't have a very strong internet. Again, You could spend minutes waiting for this, or your laptop isn't still strong enough, which of course most laptops can take a huge or big Kubernetes cluster. So there are different tools that help to automate this process, like Scaffold, Garden, and the rest of them. Most of them are open source tools, and other are proprietary tools as well. I particularly like Scaffold because it does some sort of file syncing where it doesn't have to upload every single thing in the container, but chooses specific files, which kind of makes the inner dev loop a bit fast. So here's the pros and cons for this as well. It is expensive because you have to pay for all those remote clusters that your team is using. And then maintenance is low because every single thing is already inside the Kubernetes cluster, right? So all you're just doing is deploying and then testing in there. And then the workstation temperature is normal, again, because you're not running anything on your laptop. You're deploying to the remote Kubernetes cluster and doing the stuff there. But then the inner dev loop is very, very slow because you have to wait for minutes, sometimes hours, just to containerize, deploy, and push your new changes to the Kubernetes cluster. So what you actually really want is a fast inner dev loop without having to wait for the whole build push cycle. And then we've realized that a combination of the both ways, right, where you're running everything locally and running everything remotely is almost like the best way to go, right? Because it means you would enjoy the benefits of like having stuff on your local machine, like the breakpoints, for instance, or being able to see logs more effectively. And then on the remote side, your laptop doesn't have to be super hot, it doesn't have to hang, because everything is already there remotely. So we call this remote call. That's like moving from remote to your local machine. Here's the pros and cons of that too. Well, more like pros. So the cost here is that it's cheap because everything is running remotely. The only thing that is running locally is the service that you want to change, right? So let's say I want to fix a bug in a particular application, and that bug is in the voting service, for instance. The only thing I need to run on my local machine is that voting service. And then I will connect to the remote Kubernetes cluster, which already has all the other services and all the databases. So I don't need to have that on my local machine. And another interesting thing about this is that it reduces the number of remote Kubernetes clusters your teams have to use. We have companies like VMware who moved from 50 clusters to 5 clusters with Telepresence. And then the maintenance is low. Again, everything is inside the remote Kubernetes cluster. The only thing you need to run locally is just your service that you're trying to change. Workstation temperature is normal as well because everything is running in the remote Kubernetes cluster except the single service. And then the dev loop is super fast because as soon as you make a code change, you still get to debug, you still get to add those breakpoints, you still get to see logs locally, but then you can still benefit and see all of the services running in the remote Kubernetes cluster and can now test against them. So Telepresence, which is the tool we're talking about today, embodies this approach of microservice testing. What is Telepresence? It is a CNCF tool that lets you see the impact of your code changes interacting with remote services and dependencies without having to wait for your application to be containerized, pushed to a registry, or deployed. So how does Telepresence work? Telepresence does this by connecting your local development environment, which is your computer, to a remote Kubernetes cluster via a two-way proxy mechanism, allowing you to access the remote services as if they were running on your computer, and also reroute traffic from your remote services to your local service. So I'm going to try to do a demo. We all know that the demo gods and goddesses are not always in our favor sometimes. So I will try to do that, and if everything goes well and the internet is great, then awesome. But then if it doesn't, I have a video here where I could just play and then talk you through everything that has happened. All right, so let's try to do the demo. Cool, so we have this application here called Emoji Voto, right? The application basically allows people to vote for their favorite emojis, and then it has like a leaderboard. So if I try to vote for the laughing emoji, for instance, oh, sorry, 1 second. All right, so like I said, demo gods, that's so weird. Okay, just give me 1 second. Let me try to get a new cluster. All right, it seems like the cluster that I was running on has expired. Nope, it expires in 2 hours, so you shouldn't be doing that. Hmm. 1 second. All right, so I guess I'll just have to use the video I had. This is so weird because it literally worked. Okay. So let me just quickly switch over to the video. Let me try to reload this again because it looks like, yeah, your free cluster is available and expires in 2 hours, so you shouldn't actually be doing that. Okay. All right, just give me 1 second. Let me try to log out and then use a different account to create this. All right, so let me quickly copy the link. Let me cancel this. All right, so let me try to create a new free cluster and see if this would work. Oh, still picking up the same cluster again. Okay, I'm trying to. All right, I'll just use the video instead because I can't seem to figure out why the application isn't running. So you have this video. I'm just going to walk you through the demo I would have performed now. All right, so let me play this. All right, so this is the emoji vote application I was trying to show you before it didn't work. And as you can see, it lets you vote for your favorite emojis. So if you vote for the laughing emoji, for instance, you'd see that it shows up on the leaderboard. But then there is a bug in this application. So if you try to vote for the donut emoji, as you can see in the video, it's going to throw an error asking you to choose another emoji because there's something wrong there. So let me quickly move. All right, so this is the error that it shows you and says, hey, pick another one. So I come here and then I go to my IDE, right? And then I'm going to run a gRPC call command against the emoji.voting service. So this emoji voto function is part of the voting service, which is what we're trying to fix here. So I just want to test this. Is there a way I can make this bigger? Can you all see it from there? Okay, awesome. All right, so what I'm going to do now is run a gRPC call command against the emoji voting service of vote.not, which is the function. Right, so if I run that, you see that it's going to return an error here saying that, hey, the error is unknown. And what I now want to do is to go to the file for this application and actually fix that bug. So in a few seconds, you see it's going to show the api.go file, which I'm going to scroll down to. One of the things you notice is that there is actually a bug there in that vote.donut function. Like compared to the other ones, I was returning the donuts or returning the poop, for instance. The donut function wasn't doing that. Oh, it's moving too fast. All right, so if you look at this, right, you'd see that we have the different functions, the vote donut function, vote poop function. These are the different functions that control the emojis on that application. So you can see here, vote poop, vote joy all return their respective emojis, but the donut emoji, or donut function rather, doesn't return it. So what we're going to basically do here is to change that. So I'm going to change this code and make it return the donut emoji. So on doing that, I'm going to now save my code changes. And after I've done that, I'll go back to my IDE again and run that gRPC call command. And now you can see that it actually returns a response, meaning that I've been able to fix that bug. So this is it selecting, just so you can see. I'm not sure if it's clear enough, but you should be able to see that it has shown you the response that we've gotten from this new one after making the code change. So now, after we've done that, generally, what you want to be sure, what you want to confirm is that this local code change that you've made is going to work with the other services in the remote Kubernetes cluster. And just a bit of context, the emoji voter application has 4 services. Voting service, as you can see here, it has the emoji service, the web service, the voting service, and then it has the web app. So the voting service is where this bug is, and that's what we're trying to fix, right? So instead, not with that gRPC call command that I just ran, I can confirm that what I did is working, like on my local computer. But then what I want to do is ensure that this service is going to work with the other services in the remote Kubernetes cluster. So the typical thing I would do here on a normal day would probably be to containerize this new code change, push it to Docker, and then deploy it to the remote Kubernetes cluster. That's the normal route that people would usually take. But now I want to use Telepresence, so this is how it would work. So as you can see here, I am connected to the remote Kubernetes cluster by running Telepresence Connect. So once you run Telepresence Connect, it's going to connect your local machine to remote Kubernetes cluster. What that does is basically creating a tunnel between your computer and the remote Kubernetes cluster so that you can now reroute traffic to any of the services there to the service running on your local machine. And then it would almost just feel like those services are directly on your local machine as well. So here shows that it's connected to the default Kubernetes cluster there. You can see here that the Telepresence root daemon and user daemon is running as well, and that is connected to the remote Kubernetes cluster, which contains the emoji voter application. So now, first thing I'm going to now do is log into Telepresence. So if I do that, you see that it shows that I've been able to log in successfully. And then after doing that, what I want to now do is create an intercept. This intercept is going to reroute traffic from the voting service running in the remote Kubernetes cluster to the voting service on my local machine. That's the one that I just updated some minutes ago. So I will be asked to put in my DNS, put in the ingress, put in the port number, and once I do that, you see that it's going to now generate something called a preview URL. So if I go to this preview URL, like I'm about to do that, and paste it here, I should now be able to test to see that the voting service is working as expected. So the thing with this now is that this voting service on here is the voting service on my local machine, not the one that was in the remote Kubernetes cluster. So now I can confirm that the voting service that I have updated is working with the other services in the cluster. So if you try to vote for another service as well, you'd also see that it works as expected. And then one other feature that Telepresence provides is the opportunity for you to be able to copy a preview URL of this thing and send it to your colleague. So in my case now, I've fixed that bug, and then I want to share with my engineering manager to review my code changes. Instead of having to push it to GitHub first before getting feedback and then coming back and doing the entire process again, I can just copy this URL, send it to my manager, my teammates, whoever is reviewing my code, and then they can actually see and test the code changes and give me feedback. So in the video here, you see that I copy it and send it to my manager, Erica, letting her know that I fixed that bug people complained about. She's going to click on that URL, review the code changes, and then share her feedback with me. So that way now, I have been able to test the impact of my code changes without having to go through the whole build push test cycle. And then we also have the, give me 1 second, trying to find. There's also a way for you to, so in this video, right, you can see that we intercepted traffic to a certain header. So it means that anybody who goes to this preview URL will be able to see the local changes that I have updated. But then there's also a way for you to send all the traffic to the voting service. That means that if anybody goes to the original application, so let's say the emoji voter application was at emojivoter.com, right? and then I've made a code change, and I want to test it in part of my code changes. But I want all the traffic, that's every single person who goes to emojivoto.com to hit the voting service on my local machine. That's what we call, let me go back to my slide. That's what we call global intercept. 1 second. All right, so I could just walk you through the steps now from my slide. All right, so the global intercept basically lets you reroute all the traffic that is supposed to hit the voting service remotely to the voting service running on your local machine. That way, if I send anybody here that link, they would actually see the voting service running locally, right? And you can see that it's working as expected. But this is not always a very good approach, right? Because more than one people might be using that Kubernetes cluster. Let's say I'm trying to fix this bug and my colleague is trying to do something else. So if I am like working on these changes and I add certain breakpoints while debugging locally, it means that if my colleague is also testing something on his end, whatever I'm doing here is going to affect him. So that's not always, I mean, it has its benefits, right? But then it's not always optimal. So personal intercept, on the other hand, helps you specify where you want the traffic to hit. So for instance, I can decide that I want this traffic to only hit a specific header, say all things open, right? And then it means that anybody who adds, so if you add that header to like an extension, like, does anybody know mod header here? It's one of these extensions. Does anybody know that? No, it doesn't seem like it. Oh, okay, awesome. All right, so if you add the HTTP header to mod header, for instance, it means that you'll now be able to access this alone. And anybody who goes to this application will not be able to know or even identify that I am currently running the voting service from my local machine. So this is what the personal intercept looks like. You can see here that it includes the HTTP header that I talked about, which is the Telepresence, Telepresence intercept ID, and the URL. So if I had gone to the mod header here and added that right, so I added the request header, added Telepresence intercept ID, and then added the value here. And then if I try to reload that application again, you'd see that it's going to show me the voting service running on my local machine. But then by connecting with Ambassador Cloud, it just makes that entire process faster. Instead of you to have to copy the HTTP header and put it yourself manually, it will just integrate that for you automatically. Right. So here's a quick summary of how it works with Telepresence. Without Telepresence, you typically have to code, build your container, push it to a registry, deploy, and then wait to see how it would interact with other services in your remote cluster. But with Telepresence, all you have to do is, well, not all you have to do, it just makes it easier. With Telepresence, you code, and then you go straight up into intercepting. So what that would do is move the traffic to your local machine, and then you can actually test to see if it's going to work or not. And if I could actually show you the demo, you'd see that as soon as you make a code change and click on that reload button, it's instant. You instantly see the feedback, right? And then you can share it with your manager, share it with other people to review, before you then push it to GitHub when you feel a lot more comfortable. So Telepresence is also integrated with some of the local tools you're using. We have a Telepresence extension on Docker Desktop. So if you love using Docker Desktop and want to try Telepresence out, you can also do that there. Then we also have an integration with GitHub Actions as well, where Telepresence works in CI/CD. So I've also added a picture here. I think there's a link, and then you can also read about it and see how you can integrate Telepresence with GitHub Actions. It just helps to make your CI/CD process a lot faster and reduce the number of Kubernetes clusters you'd have to use if you weren't utilizing Telepresence. So in conclusion, the inner dev loop can be very painful for microservices, right? You always have to wait, you have to deploy, like all of those minutes and those, it could be hours sometimes, makes you less productive because you're not getting an instant feedback loop. Because you want to ship features to your users as soon as possible, you need a feedback loop that lets you quickly identify what is not well, what is not going as expected, so you can go back, refactor the code changes, and repush it again. So how Telepresence does this is that it proxies your local machine into the cluster, thereby increasing the fast feedback loop. And then it enables the remote to local development I talked about, the remote call, where you still use your remote Kubernetes cluster, but then you still enjoy the benefits of working locally. So you can still set breakpoints, you can still get logs, you can still do like all of those interesting things you would normally do previously when you were running all your applications locally. And then it supports several workflows that makes you more productive. Like I shared, we have the one on Docker Desktop, we have the one on GitHub Actions, and it can also be used directly on your CLI or your Kubernetes cluster. You don't have to necessarily use it on GitHub Actions or on Docker Desktop. Telepresence is also an open source project, so feel free to contribute to the project. I've also added a link to the official documentation here in case you want to read it and see how it works. I just added a few slides for some feedback from the community. This is someone who works at Docker who talks about how he was generally impressed when he heard about Telepresence and the different things he can do to make your development workflow a lot better. And then this is a picture from KubeCon, which just happened a few days back, and one of the keynote speakers also mentioned Telepresence as well, talking about how it helped to bridge Kubernetes, right? Helped to bridge that gap between your local computer and your remote Kubernetes cluster. You no longer have to just go all locally or just go all remotely. You can still enjoy the benefits that come with working locally and the benefits that come with working remotely. Then you merge those two benefits together and have a remote call dev loop, which you can actually test off and get your feedback loop a lot faster. Thank you so much. I will add links to the video just so you can watch the demo again. And you can also see a link to our Slack channel here in case you want to join in and ask us questions. We have people there always willing to respond to you as soon as we can. Thank you so much. If anybody has questions, now would be a great time. Oh, okay. Sorry, I can't hear you. I can just quickly check. I'm not sure of the exact amount, but I can just quickly check. So there's a free version, right, which is the OSS version that would allow you to create global intercept. But if you give me 1 second, I could just quickly check that and let you know. All right. So is there any other question in the meantime while I check that? Person. All right, can you see the screen? All right, is it clear enough for you? All right, cool. So I'd be happy to chat about it. We can connect you to someone in the team, so learn about how it will work with your own specific workflow and all of those stuff. So after this talk, we could meet and chat about it. Okay, is that? Sorry, I didn't hear you. What? Mod header. Oh, okay. So this is the tool, right? This is it. It basically helps you to test certain things. So for instance, let's assume you have a better application, right? That is not in production, but then you need a specific header to be able to access it. So it's like header propagation. So how it could work with Telepresence is that if you create a personal intercept is basically saying, I don't want all the traffic coming to the voting. So let me take a step back. You have this application that you want to fix. It's in the voting service. You have the voting service running locally on your computer, right? Then you also have the voting service, which is part of the remote Kubernetes cluster. So now you fixed the issue with the voting service locally, but you want to test to see that this voting service would work well with other three or 100 services in your remote Kubernetes cluster. So one way to do that is to reroute all the traffic hitting the voting service in the remote Kubernetes cluster to the one on your local machine, right? So it means that anybody who goes to, say, emojivoto.com would actually be hitting the voting service on your local machine, but they don't know that, obviously. But you know that you can actually use that traffic to test to see, hey, is this working well? What can I improve? What can I do? Then personal intercept, on the other hand, helps you send a specific number of traffic to that URL. So it means that if I go to emojivoto.com, if I'm not hitting the same header that I specified, then I'll still be accessing the remote services voting service, right? But if I'm hitting that header, it means that I'm hitting the voting service on my local machine. And the importance of doing that is it helps many people to be able to test without affecting one another. An instance would be, let's say I added breakpoints while I was debugging, right, locally. And Alice is on the other hand, she's also using the same Kubernetes cluster. If she's testing stuff, she wants to get this impact immediately. But then since I've added the breakpoints, it means that whenever it hits the breakpoints on my end, it's also going to affect Alice as well. So to stop that or prevent that from happening, that's where personal intercepts comes in. So it's basically saying, hey, this intercept should only be for me, should only be for anybody with this header. So if I send this header to you, for instance, and even if you're on emojivoto.com, as long as you add that header details here, let me just go back here, 1 second. All right, so let's say this is the header, right? So as long as you copy this header and add it to the mod extension, so add the name here and then add the value, it means that if you go to emojivoto.com, for instance, you will be hitting the voting service on my local machine, right? It's not the one in the remote Kubernetes cluster. But every other person who doesn't have that header will be hitting the one in the remote Kubernetes cluster. I don't know if that answers your question. All right, awesome.
Thank you. That answered a question I had too. So,
Okay.
how does Telepresence intercept that traffic in the Kubernetes cluster?
How does it intercept the traffic in the
Yeah.
Kubernetes cluster? All right, so how it works is when you like trigger Telepresence, it has a user daemon and a root daemon, right? So what that works is when it starts, it creates a tunnel using port forwarding, right? It creates a tunnel between your local computer and the remote Kubernetes cluster, right? And then so when someone makes a request, it will hit the DNS. And the DNS, of course, will not know what to do with it because it's a different configuration. So the DNS will then send it through the tunnel, and then the tunnel will now pass it through to the local service. Don't know if that makes sense. What? So I guess we can just chat about it in person again, just to be sure. But yeah, that's generally how it works. So it creates like a tunnel between your local computer and the remote Kubernetes cluster. And then any request that hits that, depending on how it's structured, is it a global intercept or is it a personal intercept? If it's global, then it means every single request that hits the DNS, which could be emojivoto.com, for instance, will now go through the tunnel. But if it's a personal intercept, then it means that it needs to have that header, and then if it hits it, it goes through that tunnel.